Hi friends, today we're going to talk about the area of regular polygons. So before we actually start talking about formulas, I want to review a vocabulary word and then talk about a new vocabulary word. Okay, so the first thing that we're going to review is what makes a polygon regular. And there are two things that have to be true in order for a polygon to be regular. And those are all the sides have to be congruent and all the angles have to be congruent. So essentially a regular polygon is a polygon that is simultaneously equilateral and equiangular. Okay? So then there's a couple other things that we have to know or recognize in order to find the area. So what I'm going to do is I'm going to mark the center, roughly, of this polygon. And this is simultaneously the center of this green hexagon that I have here and the orange circle that is circumscribed around it. Okay? And so the first piece is I can draw a line from the center to a vertex. And when I do that, I have drawn a radius. And you can see pretty clearly that this is a radius from the center to the circle, because a radius is any line that goes from the center of a circle to its edge. And since all of the vertices touch the circle, any line I would draw from the center to a vertex is going to be a radius. And so going forward, that wasn't a great one. Going forward, you're not going to see necessarily the circle around the shape, around your polygon, but it's still from the center to an edge, you still know is going to be a radius. Okay? I'm sorry, not from the center to an edge. A center to a vertex is always, we're just going to call that a radius. So if I give you a pentagon and I say the radius is blank, you'll know that's from the center to the vertex. Now we have a new term for a type of segment, and that is apothem. Some people pronounce this apothem or something like that. I call it the apothem. That's what I was taught, but I might be wrong in that pronunciation. But anyways, this is the word. And what that word represents is a segment from the center to the opposite side. It's going to bisect the opposite side and meet at a right angle. Okay? So it's really important that we don't mix up our radius and apothem. The radius goes from the center to a vertex. The apothem goes from the center to the midpoint of a side. Apothem. Okay, so now let's talk about the area formula. The way the area formula works is we are going to first take 1/2. A lot of our area formulas have 1/2. Rhombi and kites have 1/2. Trapezoids have 1/2. Triangles have 1/2. So do regular polygons. So it's 1/2 of the product of the length of the apothem. So this stands for A is apothem. Times the perimeter. So 1/2 AP means 1/2 the length of the apothem times the distance of the perimeter. So let's look at what this looks like. So we have 3 examples here. We're only going to do the first one right now because the other 2 are more complex situations where we have to either use specially right triangles or trigonometry actually to find the values that we need. But this first one that we're going to work on today, we're already given pretty much everything we need and we don't have to do any more complex mathematics. Okay, so it says find the area of a regular decagon. So first let's think, what does a decagon mean? Well, a decagon means it's a polygon with 10 sides, with a side length of 8 inches and an apothem of 12.3 inches. Okay, so let's remind ourselves, okay, to find the area, I need 1/2 the apothem times the perimeter. Well, I know the apothem. It's given to me as 12.3 inches. I don't know the perimeter, but I do know the side length. So let's think about how to find the perimeter. Well, we know this is a regular polygon, which means all of the sides are congruent. So we have 8-inch sides, and there are 10 of them because it's a decagon. So the perimeter is going to be 80 inches. So to find the area, all we're going to do is 1/2 times 12.3, which is the apothem, times the perimeter of 80. And when I do that, I am going to get 492 inches squared. Okay, so we can pretty easily find the values we need and plug them into the formula. There's one more thing I'm going to show you with this example too. We're not going to do it completely, but I want to point something out. So it says if a side length is 3 millimeters, so we're going to label that, find the area of the hexagon. So notice we're not given the apothem in this case. And so tomorrow or later we'll talk about how to find the apothem given this information and what that's going to be based on. As I said earlier, we're going to use some special right triangles or some trigonometry, but in order to do that, we have to know angles, okay? So I want to talk about how to figure out some angles, specifically talking about this angle right here, which is a central angle, okay? So I'm actually going to draw 2 radii. Okay, you can tell that's not perfectly the center, but that's okay. And let's talk about this central angle. So we have, because if I were to keep drawing radii all the way across, I would have 6 of these triangles. 1, 2, 2, 3, there'd be one right here, 4, there'd be one right here, 5, and another right here, 6. So I'd have 6 of these triangles. I know they're all congruent because this is a regular polygon, which means all of these angles, central angles, would be congruent. So I'm going to have 6 of these central angles right here. And I know that together they make a circle. Okay? And a circle I know is 360 degrees. So to find one of them, I'm going to do 360 divided by 6, which is going to get me 60 degrees. Okay? So that's an important thing to keep in mind, that we can find central angles by dividing by the numbers of sides. We can do similar to find interior angles, and we actually already know how to do that, so this is just a reminder. We find interior angles by taking n, or the number of sides, in this case 6, we subtract 2, and we multiply by 180. This is the polygon angle sum theorem. So that will give us the sum of all of the angles in the inside, and then to find the measure of 1, we're going to divide by 6, because they're all congruent. And this will give us 120. We're going to use both of those strategies tomorrow to find some angle measures that we're going to need. Okay, so that's something to keep in mind.